The team brainstormed before making the AEVs. The team used a system of screening and scoring in order to decide what designs to pursue. Each team member made initial designs to present to the team. The group wanted to focus on being aerodynamic, lightweight, easy to maintain, and balanced.
Each design had differences and were chosen based on what one we thought would be the most successful. The first design was chosen based on durability and being aerodynamic, but we found that it was unnecessarily heavy. The second design was an AEV with 2-liter bottles cut in half, then put on either side of the AEV. The idea was to have the AEV have the smallest air resistance possible and possibly lighter, mimicking the shape of an airplane. While the second design was more energy efficient, there were still improvements to be made. A few changes were made to the initial SolidWorks to help make it as efficient as possible. We moved the arm to make the model more balanced while it was still running. Also, the Arduino was moved to the top of the AEV rather than staying on the bottom to help with the center of mass. The final AEV was more balanced, lighter, and the most energy efficient by far.
Yes! The program was written so that the AEV would perform all desired operations as efficiently as possible. Initially, we tried a higher wheel count at a lower power for the majority of the run. This turned out to be a huge waste of power, as there had to be a braking mechanism that would stop the coasting. We switched to a high power for a low wheel count, and this turned out to be much more energy efficient. There was no braking mechanism, and the AEV stopped on the mark almost every time. We were able to cut our power from 89 joules of energy used to 59 joules per run.
During this project, we encountered many issues. We had to take issues with the designs and use them in order to improve the AEV and the program. One of the first issues was the first design. It was heavier than we anticipated and not as balanced on the track. We tried to improve this with the bottle design, but while the bottle was very aerodynamic and balanced, it was heavier than anticipated. This was resolved by improving the final design to be lightest and more energy efficient. The design process was very useful. By using the design process in the beginning, the team was able to brainstorm our ideas to come up with the best design. We documented all our results from tests in order to maximize efficiency for the final improved design. From this project, we learned the engineering process is long and requires a lot of trial and error along with research, background knowledge, and teamwork.
In conclusion, our group improved on an initial design in order to make a more energy-efficient AEV. Projects like these on a larger scale can lead to more eco-friendly technology and a greener world.